In this tutorial, we'll explore the pre-deployment checklist provided by OpenCRVS for country implementations. This checklist is essential for ensuring your OpenCRVS installation is efficient, secure, and equipped with necessary safety features like logging and backups. Familiarize yourself with this checklist at the start of your project. Many of the items are relevant across different environments, including QA. The list includes straightforward tasks to track progress and more complex ones that might require server access and command line operations. We'll walk through the checklist, detailing how to verify each item. One. Deployment pipeline for QA, staging and production. Confirm that automated deployment pipelines are correctly established for all environments. This step ensures that the software delivery process is reliable, efficient, and that deployments can be easily reproduced and tracked. You should have one deployment pipeline, deploy production, that is only used to deploy the live production environment. There should also be another deploy, development pipeline used to deploy staging, QA, and all other non-production environments. The difference between the pipelines is that the development pipeline is also allowed to make factory resets to the environments if the developer triggering the deployment wishes to do so. For live environment deployment, this functionality is disabled completely to prevent accidents. This step can be marked as done after production environment is deployed and confirmed to be working. 2. SMTP service, tested for all emails and alerts. Validate the SMTP configuration to ensure operational email functionalities, including two-factor authentication, onboarding, and password reset notifications. It's crucial to test both transactional and alert-type emails. Start by verifying the 2FA emails, which you can easily check by logging in. Successful receipt of these emails can confirm the email transport system's functionality. For alert emails, you can mark this task as in progress for now. We will be testing alerts comprehensively later on in this video. 3. Set up DNS and SSL. The configuration of DNS records and SSL certificates can vary by country. For more detailed information, refer to our HTTPS certificates video. To confirm proper setup, access your deployed environment using a web browser. Look for a security indicator, such as the lock icon, next to the website address. In Google Chrome, for example, clicking on this icon reveals a "Connection is secure" message, indicating that HTTPS is functioning correctly. Review the certificate details to ensure they match your expectations. Pay particular attention to the expiration date of certificates not issued by Let's Encrypt, and plan to renew them before they expire. 4. Verify production backups. Restore on staging. This step checks if your backup system is working properly by doing 3 things. 1. Making sure the production server is saving backups every night. 2. Checking that the staging server downloads and restores these backups every night. 3. Testing the backup files are not corrupted. After you've set up OpenCRVS on both your production and staging environments and provisioned the backup server, you should start seeing the production data on the staging server the next day. A good way to test this is by logging into the staging environment with a user account that was part of the initial user CSV. If you can log in without needing to seed the staging environment first, then it's all working fine. You can also try changing the user details for an admin user on the production side and see if the same change shows up in the staging environment the next day. 5. Deploy the latest version. Confirm that the deployment includes the most recent version of OpenCRVS Core and the latest updates to the country-specific resource package. Keeping the software up to date is crucial for accessing new features, bug fixes, and security enhancements, ensuring the system remains efficient and secure. Alerts. Next, we will verify different types of alerts are working. These alerts include security alerts, low resource alerts, and alerts caused by exceptions happening in production for end users. 1. Alert sent for SSH login. An alert should be triggered for every SSH login. Start by opening Production Kibana to observe the alert in action when you log in. Kibana credentials were configured as part of the initial environment setup and should be kept in a password manager software like 1Password. In setups using GitHub, these credentials are stored in GitHub Secrets. After you have logged in, go to the Alerts view and then to Manage Rules. Next, open up a terminal log into your production server using SSH. In production environments, this should not be possible unless you are either using a VPN or using SSH with the jump parameter. I'm using QA Machine as my jump host here, as that's where we also host our VPN server. Upon successful SSH login, Kibana should display the alert as active. Additionally, an alert should be sent to your designated Slack channel. Once you've confirmed the Slack alert is working, you can revisit the beginning of the pre-production checklist and mark SMTP service tested for emails and alerts as complete. 2. Disk space warning and alert verification. To test the disk space alerts, we'll need to temporarily fill the disk to trigger both the warning at 50% and the alert at 70%. Now that we are already logged in to the server machine, let's first check the available disk space on the machine. df command can be used for this. The specific file system we're interested in is the one where the image file of our encrypted data storage is located in. In the standard OpenCRVS infrastructure setup, this is in the root of the file system. In this output, the file system we're interested in is called dev-vda1. It currently has 310 GB of disk space, of which 92 GB is currently in use. This means we have 219 GB available to be filled in our test. We can use a command called dd for creating a large file filling up the free space. The command should be ran with the following parameters. This command will create a file approximately 200 GB in size, 2 GB multiplied by 100. If this amount exceeds 80% of your total disk capacity, it's advisable to reduce the file size to avoid completely filling the disk, which could lead to potential issues. Pay attention to the directory where the file is being written. It should be in the same location as the cryptfs sparse image, not in the data directory where the image is mounted. Sparse images dynamically allocate more space as needed but do not release it, which could inadvertently trigger a disk space alert even after the large file is deleted. After creating the file, return to Kibana to confirm that the alerts are functioning correctly. Also, ensure that these alerts are received on Slack. If everything went as expected and you did receive an alert, you can proceed to removing the created files. Security items. While we're in the SSH terminal, let's review some security items from the pre-deployment checklist. Ensuring basic SSH hardening methods are in place is crucial before starting production use. If you're using the infrastructure configuration provided by OpenCRVS, all the following items should already be configured for you. However, it's still important to fully understand the configuration and ensure everything is functioning correctly. Let's begin by logging out of our SSH session and then logging back in. If you've done this before, you should have been prompted to set up two-factor authentication for your account. Enabling two-factor authentication for all users is essential as it prevents unauthorized access with stolen SSH private keys. Ensure that users are prompted to set up two-factor authentication and that they are required to enter the two-factor authentication code each time they log in. Username and password logins should be disabled for all OpenCRVS environments, not only in production settings. We only support authentication using private-public key pairs. To confirm that password authentication is indeed disabled, execute the following grep command. The value in the SSH configuration file should be no. We also aim to disable logging in as the root user. In OpenCRVS environments, there should be no need for anyone to log in as root. Users with access to OpenCRVS can execute commands as the superuser, which is preferable since it ensures that individual user accounts leave behind audit logs, aiding in investigations of security incidents. Use the specified grep command to check that root login is disabled. Given that our verifications are somewhat theoretical and depend on the configuration file being correctly used and interpreted, I recommend logging out and attempting to log in both as the root user and using a password instead of the SSH private key. After completing these steps, you can return to the pre-deployment checklist and tick off the SSH-related items. By now, you should be somewhat familiar with the OpenCRVS architecture model. In our model, none of the servers in production use should be directly accessible from the public internet. The public internet is full of bots and scanners trying to find vulnerabilities to exploit. Despite our efforts to make OpenCRVS secure, the most significant measure is to ensure the application is only accessible through a VPN. Let's run a port scanner on our installed environment to analyze the results. Nmap is a powerful and versatile tool used for network discovery and security auditing. It is designed to scan large networks as efficiently as possible, though it works fine against single hosts. Let's use Nmap against our environment first without a VPN and then with a VPN enabled to see which ports are exposed. Our expectation is that without a VPN, we should not see any open ports. With a VPN enabled, we should only see known ports such as HTTP 80, HTTPS 443, and the SSH port 22. Let's first run Nmap with VPN disabled. Nmap seems to think the host is down. This is because it cannot find any ports open on the server's address. This is exactly like we want it to be. For anyone in the public internet trying to connect to our environment, it looks like there isn't a server to respond. Next, I will start my VPN up and run the command again. Now we can see 3 ports, one for HTTP, one for HTTPS, and one for SSH connections. Again, this is exactly how we expected. With a VPN enabled, we are able to use OpenCRVS and log in using SSH. In conclusion, we've walked through key aspects of the OpenCRVS pre-deployment checklist, emphasizing the importance of a secure and efficient setup across all environments. From automated deployment pipelines to SMTP service tests, DNS and SSL configurations, and backup restoration checks, each step ensures the robustness and security of your OpenCRVS installation. We also highlighted the critical role of alerts and the necessity of a secure firewall setup, accessible only through a VPN. Remember, these steps are not just ticks in the box, but essential processes to safeguard your implementation against vulnerabilities. The pre-deployment checklist does not contain all risks, vulnerabilities, or safety mechanisms, so please make sure to always critically evaluate the deployment. Thank you for watching this video.